Hello everyone, thanks for joining the webinar. As we are all well aware of the fact that data pipelines are the backbone of modern analytics, and yet poor data quality and unreliable pipelines cost organizations millions annually. And to address these challenges, we have came up with this webinar, Ensure Trust in Databricks Data Pipelines using GenAI. This session will uncover how GenAI powered testing automation can transform your Databricks data pipelines to ensure trust, reliability, and operational efficiency. So, agenda for today's webinar is the business impact of data quality and understanding how data quality affects pipeline performance and business insights. Then harnessing GenAI using Datagaps DataOps suite. We'll discover how GenAI enables automated data validation, anomaly detection, and error resolution. Then cost optimization strategies. We'll learn how to reduce pipeline maintenance costs and enhance analytics accuracy. And in the end, we will discuss some real-world success stories and showcasing how automated testing builds trust in data pipelines. On the panel today, we have David Small, Global VP of Sales at Datagaps, and Shubhanshu Dikshit, Product Manager at Datagaps. Also, we have included a couple of polls in between the session, which will reflect in the middle of the session, and we will request every attendee to share their feedback by answering those poll questions. Now I hand this over to Dave. Dave, stage is all yours.
Thank you, Pooja, and I'd also like to thank everybody for attending. Much appreciated. What we have planned today is a little bit of a presentation just to talk about and position some of the use cases that we see that are coming from the Databricks community and how we can help with that. And then we'll go into a little bit more detail. Shubhanshu will go in a deeper dive in a presentation, but also follow it up with the demonstration. So a little bit about Datagaps. We've been in business for over 13 years. We offer a suite of products called DataOps Suite. That suite of products is made up of a variety of individual products in that suite. It's mostly Apache Spark based, but it also runs within a Databricks environment. It runs either on-prem or in the cloud and behind your firewalls. And we have no access to the data, nor do we have any access to the software itself. So our main vision is to do end-to-end data validation for a variety of different platforms, including Databricks. With that, if you think about a simplistic pipeline, there's a number of moving parts, a number of things that happen within that pipeline. Data is coming into your enterprise, and it could be from flat files, it could be from Databricks, it could be from other cloud sources, JSON, so on. And that data begins to move through processes to enrich and enhance that data, and ultimately put it in a data warehouse or into your medallion architecture, and then it gets consumed in your data analytics platform. So one of the first things that people do with our technology and our ETL validator is they profile the data to make sure that the data is consistent with what they are expecting. So we give you about 20 different metrics on any data elements that you choose. And we not only give you those metrics, but we also tie that back to prior profiles. And if the metrics have changed drastically or have changed, we also give you the ability to know that that's a potential anomaly and can take corrective actions. So at a high level, that's one of the first things a lot of people do. We also provide a data rules engine that gives you the capability to look at your data at a more granular level and apply business rules to that data to ensure that the data is being ingested correctly, it's the right format, it doesn't have nulls where they shouldn't be. All kinds of rules can be applied to your data as it's being ingested. Now, we've integrated AI, generative AI, into the data rules capability in that we can actually hand off the metadata, and if you choose to, you could hand off the data itself, and the data rules will be created for you automatically through Gen AI. Another area is data quality monitoring. So as data is at rest in your organization, either in your data warehouse, could be your production applications, it could be in any of the stages of the medallion architecture, what we'll do is we'll monitor the quality of that data and let you know if the quality of the data is being diminished for some reason. A lot of times people also want to do, whether you're doing ETL or ELT type of validations or data transformations and such, people want to validate that the results that you're getting are the expected results. So we have the capability to validate the data as you're creating your ETL testing or ETL pipelines. We can independently test those pipelines to ensure they're giving you the expected results. And then as you move those into production, we can continue to use those tests to monitor and make sure that that ETL process or ELT process is working correctly. One of the things we also do in the end-to-end testing is we help with the BI validation. So if you're using something like Power BI, Tableau, what we can do is we can help with regression testing. We can do performance testing, stress testing. You can write data rules against the data that's being rendered on your reports. We can compare at a graphical level. There's a wide variety of things that we do to help validate that journey. So we start at the point of ingestion, help with the transformation, validating the data anytime it's moved, has been moved properly, and then as it gets consumed in your data analytics platform, we provide you with the ability to validate that as well. Again, whether this is a standard data warehouse, could be a medallion architecture, so maybe you want to validate between your bronze and your silver level to make sure that the information is accurate and been moved properly, or even after you've done aggregation and transformations in the silver and moved it to the gold level, we provide you the ability to validate that that data has been moved correctly. We also can read Databricks, and we also are integrated with the Unity catalog of Databricks. So it's a bidirectional implementation where we can take information out of the Unity catalog and we can put information back into the Unity catalog, and Shibanshu will get into that in a little bit more detail. So that's a pretty typical use case. That's our first use case that we'll be talking about. Another use case that a lot of our customers are using is when they develop their machine learning models, what they want to be able to do is validate that the data that's feeding their machine learning model is accurate. So they'll apply data quality rules, or they'll do a data observability to make sure that that data that's feeding those models is accurate and gives you the right results, because you obviously don't want to train that model on inaccurate data. And then as that model is beginning to be used, what a lot of times people will do is they'll use our observability capability, where we learn about the data that's coming into the enterprise. We learn the upper and lower bounds. And what people do is they'll use that to see if their data has changed enough to make it where they need to redo or refresh that model. So that's another use case that people use us for. Another one is the data quality monitoring at Ingestion. Talked a little bit about this already on the first slide, but there's two ways that we do that. One is that we look at the data, we write rules against the data, we score those rules, and we roll those up to from the data element to the table to the enterprise, if you like, and we monitor and keep track of those scores. So in this particular case, if you see finances, data quality has diminished to 76, what we provide you with is a quick, easy way to trace back and figure out, okay, who's the culprit, what are the rules that are causing that problem, and you can take corrective action. Along with another way that they do this data quality monitoring, as I mentioned, is through observability. Again, what we learn through machine learning, and we learn the upper and lower bounds. And if the data gets outside of those bounds, we alert you to a potential issue. And the last use case is a lot of people have come to us with the requirement to migrate from on-prem to Databricks in the cloud, as an example. Now, what we do and the capability that we provide lays into a couple of different areas. So as the source gets moved from your, let's say, on-prem SQL Server into Databricks in the cloud, then we validate that all those tables have been moved accurately and completely. And we have a wizard where if you have hundreds of tables that need to be moved, we just simply tell the wizard, point the wizard at the tables, and it creates test cases for you automatically to validate that the data's been moved properly. It also gives you the ability to, as you move from, in my example, SQL Server to Databricks, you probably are changing your ETL or ELT process, and we independently validate that what was being produced prior to the movement is now the same that is being done to populate your Databricks environment. So we independently verify that the two ETL processes are giving you the expected results. As data gets moved to the warehouse, a lot of times people, again, want to make sure that data has been moved properly and completely, and we provide you with the ability to do that as well. And then if you're migrating from SQL Server, and say it's Power BI as an example, and you're moving to Databricks and you're redirecting Power BI to that Databricks environment, you want to validate that information and those reports and dashboards are still producing accurate results after the movement. So we provide the ability to do all of these kinds of tests. One thing, a typical deployment may look something like this, where we have a web client, Tomcat-based application server, and then a database engine, which is normally Apache Spark-based. We also have a data repository, which is where we store test information and a variety of other things. And what you can do is you can swap out the Apache Spark-based engine and swap in the Databricks engine, and give you the ability to use Databricks as an engine, not just the ability to consume Databricks data, but also use Databricks as the engine, and there's a lot of advantages to that. So with that, let me stop here and turn this over to Shubhanshu so he can continue with a little bit more detail on this and the demonstration. Thank you.
Thanks a lot for that. So welcome to the demo section of this particular webinar. Of course, since this is a webinar and not a full-fledged demo, the way we want to proceed is by playing out a few scenarios an end user or data engineer might be facing when trying to create pipelines as a whole. And for this, what I'll be using is a supplementary deck similar to what Dave was going ahead with, and trying to use that to kind of showcase what we would like to do. The first thing we would like to focus in on is a very simple use case. This is a highly simplified version of what Dave was showcasing earlier, which is the very first act of ingesting data within your system is in itself riddled with problems because you could potentially ingest incorrect data. And what we mean by this is that using left shift philosophy, it is very economical and very correct by a lot of principles to find out the issues in the data at ingestion itself, rather than finding out that the ingested data itself was incorrect at the BI layer, so to speak. And for doing this, while this is a highly simplified use case, we wanted to kind of get into the roots to kind of find how we would like to do this. So of course, the first step is to define our ingestion itself. And as soon as our ingestion is finished, we would like to do a kind of data quality check, profiling check, and anomaly check. All the things that we use to distinguish our data quality monitor. And what this is going to do, and you will see this is common across our entire problem statement, is that it's going to segregate your data into good and bad data sets. Now here the option is to ingest the good data itself and to move ahead and discard the bad data. That is just one assumption. If you're working with certain data sets, you might want to fix those bad data sets. Maybe you would like to notify the vendor that you've received incorrect data. And when we talk about incorrect data, it's inaccuracies or data that's not complete or data that's just not adheres to the business logic that was defined. These are all different things that we want to work with. And the way we define them within Databricks itself is quite straightforward. Let me just quickly open up the Datagaps tool. Here we go. So what you will see within the Dataops suite itself is that we have a data quality score system within data quality monitoring, and this spans multiple models, the raw layer, the mart layer, and the staging layer. If anyone here is familiar with Jaffle Shop, that's the particular model we are using as a reference here. And what this particular application is doing is that it's dedicating a proper data quality score, which is overall at an overall level across multiple dimensions, as you can see. And this particular data quality score can be zoomed in multiple times to fetch a particular set of validity or health of a data, be it at a table level, all the way down to a particular column level itself to see if a particular column is adhering to the specific rules that we had defined earlier. And the rules themselves are quite not complex, but simple to define. These could be rules based on the validity of data, on duplicity of data, and a lot more. You see, there's a huge volume of rules that I have defined right there, and I'll be skipping ahead into this, but most of these rules were defined using generative AI itself. But as an end user coming in, the templates that you have defined can be easily used to create these rule sets. But let's go back to a Databricks engineer trying to do this. How exactly are we working with this? For this, I have a very simple notebook. Again, the main part, you don't really have to worry about the specifications of what we've done here. The main aspect here is that this notebook deals with a lot of tables or deals with one of the multiple tables you see in the diagram that you pulled right there. And the main aspect here is how easy it is for an end user to call that particular data quality scoring system from Databricks itself. The answer is quite straightforward, very easy. Once I've simulated a bunch of raw data being ingested, I install the Datagaps integration library. And once I've done that, I just define my integrations right there. The highlighted part is what we would like to focus in on. Once we've defined our highlight, what we are doing is that we are running the data model for validating our ingestion layer. And what this basically does is that it gives you access to all the things I was showcasing you earlier, be it the output of this particular system, how many records were found, how many bad records were found, and furthermore. To show this further, I can actually go into the run history and show you exactly what this particular score looks like. You see, the application has an inherent system of capturing a lot of things. It has the system to capture data quality score. It also has the system to capture repeat offenders. Let me go to that one because that is a very interesting use case within our system. I've just switched my container into another showcase where we can see this in much more action. And you'll see that we have run the same data quality monitoring system across the dataset multiple times. And what this leads our application to do is that it leads our application to find out records which are quote-unquote repeat offenders. This particular rule set wants to ensure that whenever we are ingesting a certain column related to name, the first and last name, they should not contain any special characters or numbers because that is what we have defined. And you'll see that while the application has captured the bad records, it's also telling us if there are old records which are repeated there. This information as well is directly kind of helpful and is applied and can be used by the Databricks engineer directly without even going to the Dataops suite. And that's what we would like to do when we display this particular result, where we show that yes, the rules have been executed properly, on which particular table these rules have been executed, what was the specific rule, what dimension this rule was running ahead with, what column this rule was running ahead with, and of course, if there are bad records found, what are those bad records specifically found. So here we see that there are a few bad records found specifically, and the application is also going to give us a few sample of that particular set of bad records being found. All this is to illustrate that if you are an engineer who primarily works in Databricks and you want to define some data quality rules directly within your notebook itself, it's as easy as defining that particular pipeline and just running it from your system itself. There are a lot more integrations and other aspects as well. The focus here is on the ease for the end user, that Datoops suite can directly integrate with Databricks, not just at an infrastructure level, but also from a day-to-day process level. That was the first use case we wanted to focus in on, the fact that we can run this particular set of test cases and validations from the notebook itself. And the other subsequent aspect is that we're running the same kind of test cases from other systems as well. Now let's switch over to our deck and and look at it from a more broader perspective. So this diagram is what a typical Databricks or any kind of medallion architecture might look like. It's very similar to what we were seeing earlier. And what we have seen at this point is the very first stage, which is the validation of the data being ingested. That's the rule-based validation, as well as profiling and machine learning-based ingestion. That was what the data quality monitoring was focusing on. Now what we would like to focus in on is a very specific type of validation, which is a source-to-target comparison. Now, of course, there's going to be transformations as well as we get ahead. But here the main gist is that as we are fetching data from multiple vendors, we would like to ensure that once these are in our landing layer in their raw form, they are as expected. Basically a source to target comparison. That's what our focus is for today. For this, I'll switch over back to my system. And here you'll see that I have a particular test case with 4 components. The components are pretty straightforward because this is a very simplified version of our test cases. The first component is a Databricks notebook itself. You'll see that all it asks for us is, once we have defined our connection to our Databricks data source, just define the job ID to which notebook we would like to run. And what this notebook does the transfer. It transfers datasets from one system to the other, source to target. Once this has been triggered and successfully run, it's been successfully triggered, then we run to the validation aspect here. Now, since there is no transformation to be validated, it's a pure source to target comparison. We pick up our source. In this case, the source is our raw orders, and our target in this particular case is our staging order. So here we are kind of doing a bronze to silver one, but the sentiment still holds true. And what we find out when we run a full data comparison across the two is that, well, the migration has not been done successfully. And the mismatched rows previews kind of tell the story of what has happened. During the ingestion, because we're working with float values, there have been some random rounding issues which have caused these kind of waiver points to come into picture. Now, of course, this is not entirely a groundbreaking error, but these type of issues are what's going to cause your particular pipeline to clog up with other aspects as well. Of course, if there were records which are not present in the system at all, if there are records missing between source and target, the application would have captured them as well. And the way this particular test case has been generated, this test case in itself is auto-generated using the application based on what the source and targets were from the catalog information. More on that later. But the main gist here is, so far what we have done is that we have ensured that when we are doing any kind of migration from any particular system to and from, of course, including Databricks, this migration will be validated not just in terms of its validity in terms of score and data quality, but also in terms of completeness and how this particular cross-layer migration is working within your system. Of course, mismatched rows, column-wise mismatches, only in A, only in B, or other such data sets which the application creates. A small caveat before we move on to the next use case is that all of these are data sets that the application works with. So if there is some post-processing, which could be saving the mismatched records into a CSV file or back to a table, notifying the end user or other aspects, or maybe even fixing the bad records, there are provisions for all of this because of the numerous amount of nodes that the application comes with. Since this is a webinar, we won't dwell too much on the main aspect. What I want to focus in on specifically is that you as an end user have a lot of freedom in deciding what you would like to do before the validation as well as after the validation. Now that we have covered the first test case, let's move on to the second one. Here we would like to focus in on ETL validation. And for this, I would like to primarily focus on a silver to gold comparison, which could be, say, from staging to MDL. And here we would like to talk about something pretty critical called the Unity catalog. So let's go back to our system right there and actually open the catalog itself. So as you can imagine, a catalog is a system where you can define your tables. You can actually go into particular tables and see what this particular data set is built out of. So there's also AI generated summaries because AI generation is everywhere, even in our product. Small spoilers there. And what the application has as capabilities is to pull this particular information into its own system. This is what I've been doing here in terms of Mapping Manager. So before I move into it, let's set the stage on what we would like to do. Let's return back to our deck and open up the next slide here. There we go. So again, there's a lot of text, but the main aspect is if you can look at the right, we have highlighted a particular table, MDL customers, and this table, as you can see, is built out of two source tables, MDL orders and staging customers. The exact logic for this is provided on the left, and as you can see, each column has a bit of transformation logic associated with it. And all of this information can be provided in the Unity catalog itself at many points, or in mapping documents that your end user is going to work with. Because at the end of the day, a data engineer has to define some documentation either given to it or created by the engineer itself to define exactly what is happening in that vast sea and scattered network of tables and views that we work with. So now that we have defined this particular mapping, let's see how an end user is going to work with data quality and ETL validation as a whole. You see, the application automatically picks up this information of what your source to target comparisons are. So here, if I go back a few steps, you'll see that the sources are picked up between M orders and stage customers. The target of M customer has been picked up as well. And here within mapping, the transformation logic has been put out in plain text. The fact that we want to find out unique orders, the fact that the first order is the earliest date this particular customer had placed an order. All of this information can be provided to the end user, to our application, either via the catalog itself or manually using a mapping document. And what you're seeing right now is the main gist of why automation and generative AI is the bleeding edge. You see, the application can pick up those particular transformation rule sets and create the transformation checks in accordance to that. So we'll wait for a few seconds for this, and this is a live demo after all, but we have a few test cases created on this automatically. But what it's doing right now is that it's picking up all the information from the catalog, picking up the transformation logic associated with it, and creating the logic in accordance. So if you remember, one of the use cases was that the unique order, so count lifetime orders, is basically the number of unique orders done by this particular customer. And the application has rightfully selected distinct order IDs for this particular system to help validate this. In the same way, there are other aspects as well, where the first and last order have been defined as minimum and maximum throughout the system. It's not just this. If you actually go back to the test cases which are generated, and we will kind of quickly jump into that particular test case, you'll see that one of the test cases, and this is the one that the application had generated automatically, has this particular query built in with minimum and maximum. Whereas in the target, where we are picking up our M customer, this is the final table, we're picking the columns as is. And as soon as I open up the output of our data comparison, it kind of tells the entire story in a nutshell. While the developer came in and created the logic in accordance to what the mapping documents or requirements were, we see that when we actually try to validate it against the same logic in isolation, we find out issues. You can think of it basically as a unit test for your transformations. This can be created within parallel of your developer creating their outputs. So that is something that we work with as well. I do have a slide for it, but it's in the appendix, where we kind of delve into the true CI/CD within Dataops, which is very not really heard of within our systems. We have heard of true CI/CD DevOps, but in true CI/CD Dataops, this is what comes in, where the requirement documents are shared with both QA and developers, and both of them create their own aspects, one of development and the other one of QA. Because only when you do validation in isolation, and in this case powered by generative AI, so you don't really have to spend a lot of time working on this on a duplicity check, you can actually make sure that yes, your transformations are working as intended. Of course, the story doesn't end here with Mapping Manager, just to kind of finish the use case as a whole. If you go back to our systems right there, if I can just quickly go to data quality rules, let's just go back to this, we can regenerate our checks as well. The application has the capabilities of regenerating or generating data quality rules based on the mapping documents that were fetched from the catalog itself. Meaning that once you define your use cases or what exactly this particular column is, if I go back to catalog, it tells us what exactly this particular data sets are. The application has the capability of creating a set of rules on top of this basically in accordance to that. So there are all rules that were already generated here, and as you can see, they span a wide variety. And these are the rules that I was showcasing earlier, where if you want to ensure that the customer name is not empty, we have a use case for that. We have a validity on customer type. We are also making sure that the name is consistent throughout the tables that we are working with across multiple tables. And all of these rule sets were generated using Gen AI. And so what it kind of shows you from a broader picture is, as a Databricks engineer who has to define their test cases and catalogs and other aspects, the validation and the heavy lifting in validation is done by the application in accordance. There's a lot more to this that I'll be skipping over right now in order to save time and of course move on with the next part of our slideshow. But if you want to have a lot more look at that, feel free to look at our recent webinar on Mapping Manager, which was also done, I guess, a couple of weeks back. Now let's move on to the third use case, which is a reporting validation. BI validation in its own right is its own huge demo that we last for about 1.5 hours in many use cases, because BI validation consists of data validation, KPI validation, observability on your reports, validation of your filters, slicers, parameters, whichever tool sets that you're working with, validation in terms of security, performance, and validation of your reports, not just in terms of its unfiltered version, but also all permutation and combination of filters and slices that you apply. At the end of the day, your reports are going to be used by everyone, and everyone is going to apply a different filter or slice on top of things. So of course, that's a different ballpark. What we'll be focusing specifically here is from a medallion architecture, making sure that the numbers you see in your Power BI report are comparable either against your data model or your golden layer. So let's focus in and see what that looks like. We'll switch over to our Jaffle Shop example for this. And let's open up one of the use cases right there. So now you'll see our nodes actually look a little different, because after our validation, we have added a few more nodes. More on that in a short while. Here the problem statement is quite straightforward. I have a particular Power BI report, and I will be opening the embedded version of this particular Power BI report right now. And I need to ensure that the multiple KPIs that I see, be it output of graphs and other aspects, are valid against the data source. Because sure, I can ask anyone to make sure and ensure this particular revenue that I see is valid. I could validate it against the previous pattern seen. So is it in the same ballpark estimate as I have seen previously? That would be a bit of machine learning systems. I can also make sure it's based out of rules to ensure that it's comparable in an expected range that I'm expecting. Or something which most of us do, whoever has worked in BI here, make sure that the number is comparable against the data source itself. And that's what our focus is for today. We won't be discussing filters right now, but there's a small caveat which I'll come to towards the end. But the main gist here is that all the visuals within our BI tools, again, this is for multiple BI tools. Power BI is just an example here. We work with Tableau, SAP BO, OBI, OAC, and other BI tool sets as well. But you'll see that we have access to all the information for a particular graph, basically exported. And this information is what we kind of pull out of any Power BI report. And this particular number is what we will validate using a particular comparison. Of course, now the real question is, I say, what do I compare it against? My database. And what is your database in this case? Well, regardless of what database you are working with, the application has inherent connectivity with a ton of databases and flat files or even hierarchical files. And if you do not see something which adheres to your specific use cases, we have a CData connector, generic connectors, as well as API connectors for that. Going back to our use case real quick, here we have defined a simple SQL Server connection, and you will see that we have defined an aggregation query. This aggregation query, once again, can be generated using Gen AI to ease the process of the creation. But what the end result here is that we have a data set which is represented, an aggregate which is representative of our data sets, and we can easily compare them against the visual scene. So here we see, while there are no strict mismatches, there are records present only in one system which are absent in the other, as represented by only in A and only in B. Now, one other thing that you will see after this validation, and so you can do this for any particular test case because the application is built on a node-based system where you can add all the nodes that you have seen earlier. Here, post the validation, what we do is we automatically raise Jira tickets. We can raise ServiceNow tickets. We can send out Teams notifications. We can do a lot of other things as well, as you can imagine. And in parallel, we save the mismatched records in a very specific CSV file, or in this case, a Parquet file, as that is what our DataOps process calls for us. Now, to quickly show what this looks like if there are mismatches, I'll just switch over to another example where there are mismatches as well to cover all our bases. And in this case, let's just open up a Power BI use case. Right. So here we see a similar use case, except now I'm working with a Snowflake table, and here there are mismatches instead of data being present in one system and not the other. I go ahead with an hefty 10% threshold. Of course, everything here that you see is configurable. And the best part here is that the application has this quick sense of using fuzzy logic wherever applicable. So even if your data sets, if your column orders, if your column names don't really match strictly, the application understands which column has to be matched, takes care of data type conversions, and a lot more automatically. In fact, these test cases and a lot more can be generated using Gen AI, as we were seeing earlier. That was a quick preview on what we do when we talk about BI validation. In this particular framework, it's more on data to report comparison, but BI in its own right, as I've discussed earlier, has a good set of validations that come with it as well. The last thing, of course, is, what is end-to-end validation here? We have seen all of these things together. So let's see, when we define all of these test cases in one particular node, what does that look like? So for this, let me switch back to my Jaffle shop, as it has the good examples for this, and open up end-to-end validation here. So there are a lot more nodes here. However, there is no post-processing nodes. I could have added that as well. But for the sake of simplicity, we're kind of illustrating what the application does as a whole. We have our bronze or raw layer, we have a silver layer, we have our golden layer as well as the Power BI report that we saw here. And you will see what we are doing within a single test case is, as we load up our bronze layer, the raw data, we're performing validations and tests on top of them to ensure that the data is valid inherently as it's coming into the system. As the data gets a little massaged and pushed into silver layer, we are ensuring that this massaging is actually working as intended and not causing such issues. If such issues are coming up where there are rounding or such floating pointer issues, we want to raise notifications, we want to create reports automatically. And that's the next part of what I wanted to focus in on. And I'll come to that once I finish this example, which is that once we validate our cross-layer comparisons, once we validate our cross-metric comparisons, because, I really don't have to do a full data comparison every time. If I want to, I can run comparisons against aggregates themselves, be it against another report or against another layer. The main gist here is that the application has done all of these stuff all at once and is also going to generate a proper run history as well as a report for the end user to see, so that you as an end user can easily understand exactly what is going wrong throughout your entire system across the multiple nodes that you are working with. All of this that you see is completely customizable. You can add your very own widgets, you can connect this to your existing system. But going back to Databricks, what I really want to illustrate is that if you create your data quality score, you can actually see it back within your quality section itself. I have not run this at this point, but the quality monitoring is something that can be sent from one system to the other within our application inherently. And so that kind of covers most of our use cases here. What we have done in our demo is that we have illustrated how the application can work inherently with Databricks. And one thing that I missed earlier, I want to apologize for that and quickly showcase, is that for this particular system, the application is running on Databricks inherently. The cluster is right now terminated, as this is not a live demo, but the application can run on Databricks, can connect with Databricks, integrate with the notebooks inherently, integrate with the catalog system that we have discussed earlier, and can send results back to catalog or to your notebook as well, be it in terms of data quality rules or in terms of the output of your transformation checks. All that to say that this is just a tip of the iceberg of our product. It's very comprehensive. That's the most recent compliment that I remember that we received just a couple of days back from one of our clients. And it's very comprehensive, so it might take a while for all of the features to come into light for all for folks. With that, I would like to hand this back to Pooja and David to close us out. If there are any questions, feel free to ask them in the chat.
Yes, so thanks Shubhanshu for giving extensive demo, and let's start with the Q&A. So very first question is, how does GenAI detect anomalies or errors in real time within Databricks pipeline?
That's a very interesting question. So let's use an example to kind of illustrate this further. Say you have a typical notebook, and again, this is just a sample notebook, but say within this notebook, instead of just simulating data, you're actually ingesting data. So instead of just these print statements, you're ingesting data coming in. When we talk about machine learning based anomaly detection, what it requires the most is a bit of context. Even if you're using generative AI, it needs to know what data it's working with before it can define what's incorrect and what's correct. So in an example use case which I want to run with here, let's say you want to define what inaccuracies are, and for this let me use an example from Tableau. So let's just open up this particular use case here. And if you can look at this particular snapshot, the line chart that you're seeing right now is representative of realistic data. As you can see, the red line here represents a particular category with a lot more variance in play, but the other categories are much more stable. So imagine this, if a stable value gets not inaccurate, but like variate a very lot more, say there are multiple spikes in the stable line, that's a huge play. However, for the red line, which is naturally going to have a lot of spikes, like take for example flu shots. Flu shots are naturally going to have a seasonal sales cycle because of the sheer nature of flu itself. In that case, you need to understand that the way the machine learning models or AI models are going to work is that they're going to pick up this particular set of data sets. That's what you're seeing in our prediction model right here. Your time series is one of them. You can use a lot of other models as well. And what the application then does is that based on the previous pattern seen for that specific subcategory, trains the model in accordance. So here, regular air is the red line that we were working with. And as you can see, even though it has a lot of spikes in its, kind of ups and downs, a lot of variance, it's only calling out the spikes which break this particular pattern of variance. They were expecting the highs and lows in a certain range, and whichever values are breaking that are being caught. In a different way use case here, if you go back to regular air, you'll see that these spikes are not as varied. And the main reason for that is that if you look at your left, the Y coordinate is what's going to define that these are not as varied, because we're going up to 800 only. In the other one, we were much higher. And so here, the more stable a value is, the higher spikes come into that. That's a red flag, so to speak. So the way the generative AI or ML models work is that they work with the existing data, with the existing patterns, learn on that even for subcategories, and then call out anomalies based on what it has learned.
Thanks. Next question is, what are the key advantages of Gen AI automation over traditional testing methods?
Well, the first one I would definitely jump on is the pace. Pace and the true achievement of true CI/CD is what I would run there. Using generative AI, you can create test cases on the fly as soon as you get your requirements as well. So, at this point, if a data engineer, say there is an existing pipeline, you're a data engineer who has to create, say, some new changes to a particular set of notebooks that you're working with. So at that point, as soon as you get the requirements, these requirements get uploaded, maybe to your catalog, maybe to other systems as well. You make the changes within your notebook as required. And in parallel, generative AI systems create the validation of your changes as well. And as soon as those generative AI changes, your validations are created, both of them can run in parallel. This kind of comes into the slide which I was mentioning earlier, which is the slide after our appendix, which is this kind of slide, where if you want to achieve true CI/CD, you want to make sure that the testing that you're doing within any branch or any particular system is automated and recursive in nature. So even if there's a manual person creating these changes, the validation has to be done automatically in adherence to the requirements that are provided. And this is why automatic or generative AI systems are going to really speed up the process and make sure you're covering all bases, because generative AI system is not going to have the same biases that you might have, or a manual someone in as a person might have, and they might and not going to have any other kind of sets as well. They will be working purely with the requirements document and not looking at the code, because if you look at the code, you might inherit its problems as well. There are a lot more use cases here which we have discussed in our other webinar, but I would say pace and proper coverage without bias is one of the main advantages of using a generative AI system for validations as opposed to traditional validations.
Next is, what are the most common signs that data quality issues are impacting our business performance?
That is kind of a catch-22. That if you have to figure out that if there are data quality issues coming into your system, the business is going to call it out. One of the main things that come up, and the main reason that a lot of people come up to us is that, they find out, hey, our BI reports are not as accurate, because in the business end, someone is going to look at it. Because if you have 1 million records, the data engineer is not going to sift through all of the 1 million records, and it's very easy for cracks to kind of pass through an existing pipeline. But the BI layer is a place where at the end a human is trying to look at that particular number. A human is actually seeing whether these numbers make sense or not. So while these errors get caught at the BI layer, it's much more realistic that they're not made at the BI layer, they're made throughout the entire pipeline itself. So I would say that the main sign of data quality being lacked is a lot of complaints from the BI side, a lot of breaking of the ETL pipeline itself due to, say, incorrect data, inaccurate data, or maybe data coming in different formats and your data pipelines breaking. So while I would say that these are the main use cases, which is data pipelines breaking or inaccurate data passing through or having a lot of duplicity and other aspects within your data quality checks, if your BI layer and your human users start to not trust your data, that's a huge red flag. And that's where we need to make sure that your data quality is up to the mark. Because if you're collecting all this data and you can't trust it, then there's no point to it all.
So that's it for today's. And on a closing note, thanks Dave for sharing the how easy automation testing Gen AI DataOps suite could ease the process of validating the data pipelines, Databricks data pipelines, and Shubhanshu for an extensive demo of Datagaps DataOps tool. Then thanks for staying with us, all the attendees, all this whole time. And we have I have dropped our personal, if you require any personal demo, you can drop a note to contact@datagaps.com. And for Datagaps DataOps free trial, I have shared a link in live chat. Okay, so that's it. We have on screen you can contact us at contact@datagaps.com. And let's catch up at another webinar this month. Thank you, everyone.
Thank you, folks.